So when we're working with images in Photoshop, generally what you want to do is you want to apply a color space for the destination for that image. So generally, if you take an image in RAW format, for example, that's going to give you the widest variety of options. So you can apply different color spaces to it. So for example, you can create one copy, no, you can process the RAW file into a JPEG file that has, say, an Adobe RGB tag. And then you might process it into a separate JPEG that has sRGB. Then you can process those separately, one destined for the web and one destined for print. Then you'll be able to ensure that you have the same photo applied in the most number of places. So if that sounds like a lot of work, because it is, and you have to do adjustments to it twice, I recommend taking photos in RAW again and applying as much correction as you can before processing the RAW file. And then, because you can add quite a bit of contrast and adjust a variety of settings to get it pretty much how you want it to look, except maybe some pretty fine changes that you want to do, or even any major drastic changes in Photoshop that you want to make. And then if you really want to destine it for print, I think was the question before, and then you need to later send it to say Flickr or to somebody online, then what you might want to do is process it first in Adobe RGB because it has the larger gamut, and then you can do a convert down to a smaller gamut. So let's see. Well, this is all right. I have to do something slightly different here. I would just want to show you that there is an option on Photoshop. So if we have an image open, this one here, for example, what you can see is, let's see. I think I have to open a photo proper. I hope I have one that has a, let's see. All right, no, not that one. Where do I have a photo? Oh, I know where I have a photo. Okay. Now, I'm just opening up a RAW file in Photoshop just so that you can see quickly some of the options that are provided to us, assuming my computer will work. All right, so you'll notice that at the very bottom of the screen, it tells me the color profile. So in this case, it's going to, once I process the file, it's going to process it into an sRGB profile. But if I click on this, I can actually modify which color profile I want it to go to. So if I was going to destine it for print primarily and then the web as a secondary means, then I would probably pick Adobe RGB, open the image just with the defaults for now, and then after several moments, because my computer is slow, I can see that I have some options available to me. Let's see, RGB, oh, I did 16-bit. Oh, this has just been one of those days where it's one thing after another. So the mistake that I made was I processed it in 16-bit. That's not what I wanted to do in this case, because I'm going to just be doing a little bit of work on this particular image. All right, now after a little bit, I can, let's see, I have some options here. You can see that underneath where I had color settings before, I could use assign profile or convert to profile. You almost will never use this assign to profile unless, there's very few exceptions to this, unless you are provided an image that does not have a profile built into it and you know it should. So in that case, then you might want to assign it the proper profile, but otherwise you will never use assign and you should use convert. So in this case, I've done whatever changes I need to do to this particular image. I can convert from, you can see the source space is Adobe RGB, and I can change the destination space to sRGB. And what's nice is that this provides a preview to me so that I can see sort of a before and after. But luckily, because there's not a lot of green in this particular image, there's not a very big change. So this convert will be, actually will go relatively well. So I want to do a perceptual change, click OK, and then now I will have an sRGB image that I will be able to post online or do something with. Okay. Now, going back to this stuff, we do have some more stuff to talk about. So that is a lot of the color management aspect of this. And this is a very wide, there's a lot of information available. It can get very complicated, but I hope that this at least gives you an idea of somewhere where to start, or at least get a good foundation for this to be able to use or start using color management. But there is something else that we have to talk about within this color lecture as well, and that is this idea of white balance. And as you know, white balance can be applied to an image, or is applied to an image, when you take a photograph, and it basically defines, you know, the colors or the color cast that particular image will have. And so we have color, or rather white balance, is usually denoted by a number and then a K. And this means that it's some degrees Kelvin, which is, if you're familiar, it's actually a temperature rating. So why might we have a temperature rating for white balance? Here's it. It is very close to the temperature of the light. I heard something else. I'm sorry? Tones. So yes. Well, it does. The number does define the tone, but the reason for this. Oh, yep.
Isn't it for different elements, like what color would be?
Right. So even more specifically, there's this concept of if we have just this object in space. Imagine we have this very big rock in space, and we heat up this rock to some very high temperature, you know, thousands of degrees. You can imagine that this rock would become red hot, right? It glows a specific color. And as we increase the heat on this, and as this object becomes hotter and hotter and hotter, the light goes from this red down to this yellow, down to this blue, and it becomes white hot, right? So it goes from this red hot to this blue hot to this white hot. So the hotter something is, the cooler its light will be. Okay, so if that makes sense. So because of the way that we call these colors, where blue tones, or where blue is cool, green is cool, and red is warm, it's opposite. It's not intuitive. It's the opposite of what you would consider. But you can imagine that as you might know, the hotter something is, you know, it's going to give off like a bluer cast, and that is where this number comes from. It's specifically called this black body radiation temperature, and that is what this comes from. And so our sun is a black body, and it produces a specific color temperature, but it emits, so there's this color temperature which just emits a spectrum of light. So it's still emitting wavelengths, but it's just where the majority of those wavelengths are. So we might have like a lot of light, for example, that peaks here in this yellow, or we might have a lot of light that peaks here in this blue. And the reason for this is that the shorter wavelengths, these 400 nanometers or even shorter, represent higher energies. So the hotter something gets, okay, I'm getting distracted here. It's all a big tangent, and the geek in me comes out. But basically, all you have to know is that the higher the color temperature, the cooler it's going to be. So when we try to combat this, if we take a photo and, excuse me, if we take a photo and we know that its color temperature of the source was about 500 K, and we actually change the white balance slider to be higher, to be 9,000 K, it's going to combat that by making it look a little bit warmer. So let's see. Oh yeah, so just to give you an idea, if we have here on this same sort of color space, you can see how these, or where these color temperatures fall onto a particular spectrum. And so typically what we're used to seeing is somewhere around this, I don't know, it's about 7,000 or 6,000, 6,500 Kelvin range. That's sort of daylight. That's what we consider to be white. And what we can do is we can define a color temperature. When we take a photograph, the camera by itself doesn't really understand the discrepancies in the color. So even though we are very, very good and very adept at adjusting to the various color temperatures that can exist. So for example, even though when the sun is lower in the sky, it'll be a warmer amount of light, white still looks white to us, but it doesn't to a digital camera. And that's where this white balance comes in. We have to try to compensate for that difference in color. Now, realize that we are mapping this physical property, this idea of a black body radiation, and giving off all of these wavelengths, et cetera, we're mapping it into a more complex subject, because fluorescent lights, for example, and some other, especially commercially available lights, don't have a very even, nice spectrum to them. They have very specific amounts. They have spikes in the colors that they emit. So they might emit a lot of green, for example, and a little bit of another wavelength right next to it. And so it's not going to always look, the distribution of colors isn't always going to be like that. And so this topic is difficult, not for us so much, because it's easy for us to understand that light has different temperatures. It can be cooler or warmer, but it's difficult for a camera. And it's specifically difficult for it to determine what the white balance should be for a particular scene. And any of these artificial light sources can be very complicated and difficult for a camera to get right. And another time that it can be difficult is if you have two different light sources that emit two different color temperatures. That can also be quite difficult for us to do. Now, as you might know, when we're dealing with the raw format, we actually have the best capability of adjusting color temperature. So the white balance is not set in a raw file. So you can go back later and fix what your camera did wrong. So if all of the arguments before hasn't convinced you to at least try using raw, then hopefully this will, because I'm sure there's been some times where you take a photo and its color just looks really off. It just looks horrible. And if you took it in JPEG, it's really hard to correct, and it's really hard to correct well. And in fact, it's almost impossible to do and retain the quality that you had originally. But doing it in RAW, it actually becomes very, very possible for us to do it quite well. So let's see. Just as an example, I have a couple of photos here where the camera, I took the photo, and it was either difficult for the camera to get right, or it just didn't. So in this photo, for example, this is a photo of a sunset. So it has a particularly warm color, well, okay, I'll have to make it a little bit brighter just so that you can see. Oh, come on. So in a few minutes, you'll see that normally what you would see is this sort of, there's some green grass down here along with some houses that you can sort of see. Hopefully it will display in a sec. No, well, I can try that. I might have to make it just a little dark for a second. Okay, here, so I just made it a lot brighter, and so you can see the green. And so this is now the corrected color temperature, but please hold. Oh no. But, ... Stop being like this. You're embarrassing me. Okay. All right, so here I have a white balance adjuster up here. And I can use the original shot settings. And so, well, unfortunately, this has kind of been destroyed because I had to increase the brightness a lot. But as it was originally shot, the green area was not actually green at all. It was overcompensating for the huge amounts of color that were available in the sky. And so I actually had to modify the color temperature to be able to do it. Now, what's neat is that you can, most of the time when you take a picture in RAW, you can do what's called a click color temperature. So you will sometimes have a little eyedropper like this, where you can click on that and then you can click on a set of pixels on your image that should be white. So maybe this little house, for example, right here. Now, if you're, okay, now we can see that it has made this white and the greens are more correct and a variety of other things. Now, if you're taking a photo of something where color is of the utmost importance, then usually this is a pretty good way to go. Take the photo in RAW, but what you can also do is first take a photograph of something that you know should be just pure gray or pure white. So there's overpriced little cards that will do this for you, but you can also literally just get good enough with results with like a sheet of paper, as long as it's not lined or something like that. Just take a picture of that with, not right in front of the camera, but a good distance away, so you get the light hitting off that. Then you can get that color temperature using this eyedropper and then apply that same color temperature to all of your subsequent images, and you'll be able to adjust the color for a variety of situations. Now that will only remain true as long as the light doesn't change. In this case, that would probably be a bad idea because the light is changing literally by the second, and the color is also changing as the sun goes down. And so I'd have to be retaking that photo over and over and over again. Now, if you insist on taking a photo in JPEG format, which is fine after the class, I guess, what you can do is set custom white balance on your camera. Now, this is usually different. The steps are different depending on what camera you have, but generally you do a similar thing. You take a picture of something white and you fill the frame with it, and then you tell the camera that you want to use this photo as a custom white balance marker, and then it calculates the white balance from that, and then you can set the camera to custom white balance, and it will use that white balance in all of the subsequent photos. This is particularly useful if you are taking photos of a very constant amount of light. So if you have like a home studio with some flashes set up, or even not even some flashes, but just some desk lamps or just something set up, then you will be able to use this to adjust and correct your color quite well. Okay, now just to give you an example of a difficult situation for us. Let's see, so this photo here, which we saw just prior, is actually a very difficult situation for a camera because there are a mix of lights. So there are these fluorescent lights that exist around the building, but then there's also the lights on the car itself, and then some additional flashes that were used to provide additional illumination. And so we have this change, we have this variety of colors that we could use. So I could try to use this eyedropper and pick one. Now, if you have a situation like this, you're pretty much out of luck. You can usually find a white balance that is acceptable to you, but you have to kind of fish around for it and find out what works best for you. So clicking on this, it works fine. The colors look good, but now the problem is that it just looks it looks dull. The colors are not as good. What you generally want to do is find a region that is white that light is reflected off of. You generally don't want to click on a light source itself, as that will just bring you probably back to your original problem. But a reflection of a light is generally a good way to go. So if I can do this well enough. Okay, well, it's hard to do right here. At home, I'm a pro with this, as I'm sure you can. Okay, that's not good. All right, well, you can imagine that I click on this spot right here, and it looks awesome. And it really does. All right, that's a bit better. Okay, yeah, I like that. That's a lot better. So now we've adjusted for some of the color, so it doesn't have that yellow cast that it had before, but it retains some of the color rather than looking purely metallic and looking purely gray. And so this was the look that you wanted to go for. And really, it can take some experimentation by clicking on different things, but at that point, what you might want to try to do is literally just adjust the color temperature until you see something that looks good. So remember that I talked about when you have higher temperatures, it's a bluer light, right? And so to compensate for that, when we increase the color temperature slider here, we're going to make it more red. We're going to make it warmer to compensate for the cooler colors, if that makes sense, okay? So this now is, because it was opposite before, now that it's opposite again, this is now how we would expect it. By increasing the temperature to be higher, it actually appears to be warmer in this particular case. And so by adjusting these sliders, you'll be able to find a particular color temperature that suits you and your particular photo quite well. I'm sorry? It's a 135, not an M3. Okay, yes, another question.
Did you have original value on that temperature?
Did I have original value?
Yeah, because when you adjusted it, like, what would be the difference if you
I'm sorry, I'm not sure I know what you mean.
When you were sliding the scale, adjusting the color temperature?
Yes.
What was when you imported this photo into this program,
Mm-hmm.
was there a value that you started out with?
There is a value that, so almost always the camera will do an automatic white balance and embed that value into the file, and then you will be able to, well, it will assume that color temperature when it's processing the photo. You can override that, and that is what we're doing here. Now, this particular piece of software I think sucks. This is the Canon software, and it doesn't actually tell me what the as shot color temperature was, because if I go to shot settings, then I notice that it goes to the default, and then whenever I go to color temperature, it always shifts it for some reason, no matter, even if it's straight out of the camera, so I don't actually see what it originally was. But good pieces of software like Aperture or Adobe Camera Raw or Lightroom will tell you what the original color temperature was, and you can modify from that point. You can modify to make it cooler from that point, to make it warmer. And sometimes you are also given additional values as well. You can make it a little, you can add more magenta, you can add more cyan. It really just depends on what you're trying to do. Well, one quick announcement. So I think we are not going to do the section on Wednesday, right? Because that is the day before Thanksgiving, and it's probably not a good day for that anyway. But if you have any questions, please do feel free to email us directly, and we'll be able to answer them. So with that said, thank you all for coming, and we'll see you next week.